Based on past experience, a company knows that an experienced machine operator, which means 1 or more years of experience, will produce a defective item 1% of the time. Operators with some experience, that means up to 1 year, have a 2.5% defect rate, and new operators have a 6% defect rate. At any one time, the company has 60% experienced operators, 30% with some experience, and 10% new operators. And what we want to do is to find the probability that a particularly defective item was produced by a new operator. So you clearly notice here that we have a whole bunch of different events and corresponding probabilities here. So we need to start matching up those events with some probabilities. So let's start out. Let's go ahead and identify the events, and then we'll match up the corresponding probabilities. I've written the problem statement up here in the blue box. And so now let's start looking at what we see in the problem. So first of all, let's let D be the event the operator produces a defective item. If we need to know if the operator produces a non-defective item or a good item, we could call that the complement of D, but here I don't think we're really going to need to worry about that. Let's let E be the event, an experienced operator. Let's S be an operator with some experience. And let's let N be a new operator. With those 4 events in mind, now let's look at those percentages and convert those into probabilities. So first of all, we know that P of E, or the probability of getting an experienced operator, is 0.6. We know P of S, the probability of getting an operator with some experience, is 0.3, and P of N, the probability of a new operator, is 0.1. So I see that up in the problem statement with what I've labeled here in green. Now we've got these other probabilities here, the 1%, the 2.5%, and the 6%. And what those are is probability of a defective given an experienced operator. So it said an experienced operator will produce a defective item 1% of the time. So that's 0.01. It said that an operator with some experience will produce a defective 0.025 probability, or 2.5% of the time. And if you have a new operator, they'll produce a defective 6% of the time, or the probability of 0.06. So I need to recognize that I was being given some conditional probabilities here. What I'm trying to find is the probability that a particular defective item was produced by a new operator. So I'm being given that it's a defective. So you see the given D here. I want to know the probability that it was made by a new operator. So I've got all my numbers here. What I need to do now is to go ahead and build a tree diagram for this. Your textbook doesn't go too heavily into trees. They do it a little bit, but I find it really makes these problems incredibly easy. So if you'll look at what you've been given here, you've got E, S, and N. That's going to be your first set of branches in your tree diagram. And then if you get to E, S, and N, you go to D. So let's draw that out. So you'll see you can get to experienced, some experienced, or new off the first branch. And here we see those probabilities, 0.60, 0.30, 0.10. If you get to experienced, you might produce a defective, or you might produce a non-defective or a good item. So if defective was 0.01, they produce it 1% of the time. That means 99% of the time they produce good. So if you have some experience in your operator and he produces defective 2.5% of the time, that means that 97.5% of the time he'll do good. So your some experience operator can do defective or good, just like the experience could. Now, if you have a new operator, 6% of what he does is defective. That means that 94% is going to be good. So even though they didn't talk about good in the problem, I can actually fill that out on my tree diagram, because what these guys are going to produce are either going to be defective or they're going to be good, one or the other. Now we're going to talk a little bit about Bayes' theorem. The problem with what we've been dealing with before is the probability that we're looking for is probability of n given d. So I want to know the probability that the person was new given that they were defective. Now that's exactly opposite to what we see here. This is probability of defective given new, and I want to know what it is the other way around. And that's where Bayes' theorem comes in. So I don't want you to memorize that long, nasty formula that you see in your textbook. Instead, I want you to memorize an approach that's based on some steps that I'm going to show you here. We know what the definition of conditional probability is. Probability of A given B is just equal to the probability of A intersected with B divided by the probability of B. Let's go ahead and solve this for probability of A intersected with B, which means we have to multiply both sides by the probability of B. So when I do that, I get probability of A given B times probability of B equals probability of A intersected with B. Now let's utilize that same kind of thinking, and let's do this time, instead of A given B, let's do the probability of B given A. So that means with the definition, that's the probability of B intersected with A divided by the probability of A. We'll go ahead and multiply both sides by P of A, which gives me probability of B given A times the probability of A equals probability of B intersected with A. One of the things you should notice about intersection is that A intersected with B is the same as B intersected with A, so that means the probability of A intersected with B is the same as the probability of B intersected with A, and that's what we got out of these two previous slides. So equating those two things, we know that probability of A given B is the same as the probability of B. That matches up with the probability of the intersection, and that's the same as the probability of B given A times the probability of A. That, in effect, is what Bayes' theorem is. Bayes' theorem says that probability of A given B times probability of B is exactly the same as probability of B given A times the probability of A. What this does is it connects the two types of conditional probability, with A given B with B given A. And in fact, in the problem that we were just working with, remember, we're looking for the probability of a new operator given that they produced a defective, but the information in the problem is given probability of defective given a new operator, exactly the other way around. What we're going to do is we're going to use this Bayes rule, but we're going to use it with the events that we're interested in. So probability of n given D times probability of D, that's exactly the same as probability of D given n times the probability of n. What we need to solve for is the thing that we don't know, which is this probability of n given D. So we're going to go ahead and divide both sides by probability of D. So we get probability of n given D is equal to probability of D given n, now that's labeled on our diagram already, times the probability of n, that's also labeled, divided by the probability of D. Well, that's something that we can find from our diagram. So let's go ahead and start putting in the numbers. Probability of D given n, that's the 0.06 given new. What's the probability of defective? Probability of n is just the 0.1, so that gives us everything on top. Now to figure out what the bottom is, we have to figure out the probability of defective, but there's a lot of different branches that get us to defective. We can go new defective, some experience defective, or experienced defective. So we have to figure out what the probabilities are along each one of the branches. We multiply along the branches and then add up the individual branches. So the experienced defective would be 0.6 times 0.01. The sum experienced defective is 0.3 times 0.025. The new defective is 0.1 times 0.06. So if I work all of that out, I get the probability of a new operator producing a defective is 0.31, or 31% of the time. So the key thing to look for when you're doing these problems is if you're given a conditional probability and they're asking you to find out the other conditional probability with it flipped around, you're going to want to go ahead and take advantage of this by working out the Bayes theorem, solving it for the thing that you're looking for, and then reading off everything you need from your tree diagram.